Hello everyone, my name is Shyam Manavat and I welcome all of you once again in the new chapter, new concept of number theory, number system. This is Remainder Theorem. Many students confuse this with the unit digit concept, but it's totally different. So let's understand what is Remainder Theorem. Here, the Remainder Theorem, before we jump on to the exact theorem, let's understand the relationship between dividend, divisor, quotient and remainder. Remainder, it's very simple what we have studied in the school time. If I have, let's say, 73 which I am dividing by which number, let's say 6. Okay, so now here this 73 is the dividend, the number which is being divided. 6 will be divisor, 1 which is dividing, divisor. Okay, and here the result which you get is quotient, right? And if I simplify this, so 6 ones are 6, here you get 1, then 3 2s are 12, remainder here 1. So here what is remaining without using decimal in quotient, what is remaining at the last is remainder, right? So this is your remainder, and today's concept is all about understanding and focusing only on remainder. So here we don't care what is quotient, we'll only focus on remainder, right? Now what is the relationship between dividend, divisor, quotient and remainder? I'm sure you all are aware about. Here the dividend is equal to quotient into, quotient is this here, into divisor is this one, plus remainder. Okay, this is a general relation. Okay, here you can see this, that 73 can be written as 6 into 12 plus 1, right? Okay, so how are we going to apply this here? When finding the remainder of the product of value, so you need to just focus on the remainder. As I said, focus only on the remainder. Now think about it. Suppose if I have number, say example 2 into 2 3 multiply by 3 4 5, any number you can take, multiply by 4 1 8, and this entire product, once we get the entire product, the result of this product, when divided by 11, we need to find and focus on what? Remainder. Find the remainder. What do we need to do? Find the remainder. Okay, so here remainder theorem says that when you are going to have this kind of expression and a common divisor, you need to find out remainder. You can actually find the remainder of the individual numbers and apply the same operator, same arithmetic operator which is there with them, like here multiplication. Okay, so here instead of multiplying this entire number and then dividing, we can also take individual number and divide and check what is the remainder, and with all those remainders we can apply the same arithmetic operator. So see how it works. If you divide 223 by 11, what is the remainder do you get? Yeah, quick. Here, the 11 divisibility we have discussed in this divisibility rule. That's the second chapter of number theorem. We have discussed that, right? So we have discussed 11 divisibility as well there. So I assume that you know that. So here it will be like 2 plus 3 is 5 minus 2 is 3. So here you will get 3. Although you can also see that 11 2s are 22, 11 2s are 22, so what is left is only 3, right? Then here you say this is 3 4 5, so 3 plus 5 8 minus 4 is 4, so here you should get 4. Okay, and then here 4 plus 8 is 12 minus 1 is 11. So 11 when divided by 11, remainder is what? 0. Okay, यहाँ पे 0 है, एक थोड़ा change करते, let's change this number. Rather, let me take 411. Okay, because if I take one of the number which is divisible by 11, the remainder is 0, and 0 when I apply the same operator which is multiplication here, then 0 multiplied by everything will be 0, right? So if one of the number amongst the number which are in multiplication, if one of the number is divisible by 11, then the product will also be divisible by 11. This is very simple and straightforward, right? This we used to do earlier also, right? Okay, so I'm changing the number so that it is none of them are divisible by 11 now. So if I check this now, so here 1 plus 4 is 5 minus 1 is 4 again, so here I get 4. Okay, so what does it mean? That if I multiply these all numbers and then I get a result, and that result if I divide by 11, I will get the same remainder which I will get by using only remainders. Okay, let me remind you, we are talking about a remainder theorem, so we will focus only on remainder. We don't care what is quotient. Okay, same the way we have done in the unit digit concept. We need to focus on unit digit. We don't care what is 10th digit, 100 digits or so, right? Remember that? And that's where students get confused. They feel that it is same. It's not same. Some of things are matching, but you'll be able to deal with it, right? Okay. So if you simplify further, here you have what? 3 4s are 12. Now you can apply little extra smart work here and say that, okay, if I have a number which is more than the divisor, yes, this is something which we should always remember, that remainder can be equal to 0 or more than 0 but less than divisor. Okay, that means if any number divided by 6, the remainder will be less than 6, like 5 to 0, anything between 5 to 0. The moment it becomes 6 or more than 6, you get opportunity to divide it further, right? Similarly, here when you get 3 4s are 12, 12 is a number which is more than 11, you further divide it by 11. Did you get it? This is how we are applying, we are using smart work, yeah? We are doing smart work here. So here again, remainder is what? 1, and then this one multiplied by 4, what we get the final remainder to be 4. So even if you do this 4 12s are 12 4s are 48, 48 divided by 11, remainder is how much? Again 4, correct? So keep in mind, the moment you get number which is more than the remainder, you can further divide it, because your sole objective is to get remainder. You don't care what is the quotient. Is that clear? Okay, now it works for multiplication, it works for addition, but we cannot be very sure about the subtraction, and we can definitely not do with the division operator. What I'm trying to say is, if you have say 441 divided by 123 and then the result further divide by 11, find the remainder. No, it does not work in this case. It does not work in this case, right? Subtraction you can do, like if I take the same example here, 441 minus 123, and if that has to be divided by 11 to find the remainder, it can work here. Okay, so product in addition case, in product case for sure, and majority of the time you will get product case, because you can add or subtract, you can anyway do this very easily, right? It will be easy to subtract this 441 and 123, get the result, and then divide by 11. It's easy, right? But what will be difficult? Difficult will be if I have 441 multiply by 123 and then divide by 11. So now here in this case, which is a shorter way? Which is shorter way? You got two ways. Which is a shorter way? Two ways. One is you actually multiply 441 into 123, and then you get the result which you divide by 11 to get the remainder. Yeah? The sole objective is to find what? Remainder in this chapter. Okay? In this concept. The other method is what? You take individually 441 and 123 and check the remainder for each term divided by the common divisor 11, like 441 divided by 11, the remainder is 1. And here if 123 divided by 11, okay, let me change this here. Again 123 I have taken, no, okay, fine, chalega. Now here I have what, 3 plus 1, 4 minus 2 is 2, so here 2. So which is easy? The first way, where I multiply these two numbers and then get the result, which further divide by 11, which then divide by 11, or I can divide these smaller, easy sundar number by 11 simply and say, okay, here remainder is 1 and remainder is 2, so 1 into 2 is 2, so answer is what? 2. The remainder, when 441 multiply by 123 divided by 11, the remainder is how much? 2. Okay, so which is easier? Obviously second is easier, because you are doing small calculation, you are not doing huge calculation, you are not dealing with big numbers, you're dealing with small numbers here. Yeah, so that's why in exam you mostly get the product as an operator or power as an operator in the CAT exam or in the exam which you are targeting, right? Okay, so let's see some more examples. So here we have example number 1. If you want, you can pause this video and try solving this. The question is very similar to how you see the previous product operator, right? Here 7 raised to, this is 7 raised to 100, 7 to the power 100. Now what is 7 to the power 100? This can be written as 7 into 7 into 7 into 7 into 7 into 7. How many times? 100 times multiplied. So it works similar to what we have taken example here, that multiply, you have some numbers in multiplication and you have a common divisor. How do you simplify? How do you find the remainder in this case? Okay, so here the remainder in this case, same thing, this entire thing divide by 6, we need to find remainder. So focus on remainder. As I said, if you need to find out remainder, only focus on remainder, right? So here if I take each of these numbers individually and divide by 6, what will I get? Every 7 when divided by 6, you get, each time you get remainder 1, right? So we need to find out remainder, focus on remainder, don't worry about the quotient. I'm repeating this. So here it will be 1 into 1 into 1 into 1, how many times? 100 times. How does it matter? 1 multiply itself 100 times or 1000 times, you are going to get the product as what? 1 itself. So here you get the product as 1, right? So answer, remainder, this is the remainder which we are working on. The remainder, final remainder is 1. Okay, let me explain you this once again so that we don't have any issues further. Here when I have 7 raised to 100, it means 7 multiply itself 100 times, and if we divide this by 6 to find the remainder, I will check here this 7 when divided by 6, remainder is 1. So this is nothing but the remainder of overall expression 7 raised to 100 should also be 1 raised to 100, and 1 raised to 100 gives you remainder as what? 1. Got it? Okay, so I hope you got the answer. Let's see, we have more examples here. Okay, let's check more examples. Now this time we have 8 raised to 123 and divide by 9. Now pay attention here. We are learning something new in this case. We will take a hypothetical remainder which is a negative remainder. Okay, let me explain you the negative remainder first and then we'll go on to the question. Any number, let's say if I divide a number by 6, okay, divisor, yeah, pay attention, otherwise you may get confused later, so pay attention here. So if I take divisor as 6 and I get remainder as 5, okay, that's how the remainder should be, because if you see here, the remainder has to be more than equal to 0 or less than divisor. It cannot be less than 0, it can't be equal to divisor or more than divisor. This is what remainder mean, okay? But here we can assume, we can take a negative remainder just for help. We need help, so we can, just for help we can take this, right? So here I can say divisor, if divisor is 6 and the positive remainder, the real remainder, I should say not positive only, but real remainder is 5, then I can assume a negative remainder as 5 minus 6, which is minus 1, okay? Any number when divided by 11, divisor is 11, and if I am getting the positive remainder as 8, the real remainder as 8, I can say the negative remainder is 8 minus 11, which is minus 3, okay? I can assume it to make it easy, simplify it. And by assuming this negative remainder, suppose if I get the final answer also in a negative remainder form, the final conclusion also in the negative remainder form. Example, if the negative remainder is minus 4 when I divide by 7, then can you tell me what should be the real remainder? Yes, real remainder will be 7 minus 4, which is 3. Are you getting this example or not? Yes or no? This is what, let's call it concept of negative remainder. Works? Okay. In this case, here, let's apply that negative remainder concept for this particular question. See, I can show you with the positive remainder also this particular question, but we have learned new concept. Let's try that concept. So negative remainder concept here, when I have 8 to the power 123 and the divisor is 9, what is the final remainder? So can I say when 8 divided by 9, the remainder is 8 itself, right? Or I can say real remainder is 8 itself, right? So can I assume the remainder to be 8 minus 9 as minus 1? Think. Negative remainder concept. Real remainder minus divisor. I can assume that to be a negative remainder, right? A real remainder minus divisor. I can assume this to be negative remainder. What is the benefit of doing that? Why are we getting into this negative remainder? What is the benefit? The benefit is, if 8 divided by 9, the negative remainder is minus 1, and now you know if you have power. So minus 1 to the power even. This I don't have to explain you, right? Minus 1 to the power even is plus 1, and minus 1 to the power odd, negative to the power odd is what? Negative itself. That means minus 1, right? Okay. So in this case, if I use this negative remainder concept for this question, this particular question, I can say here it is minus 1 raised to 123 can be the remainder, okay, when you divide by 9, correct? And you know, if minus 1 raised to 123 is the remainder, then the simplified version minus 1 to the power odd will remain minus 1. That means the negative remainder here we got as minus 1. Then what should be the real remainder? What should be the real remainder? In that case, the real remainder, shall I show you the example once again? The real remainder is the divisor and here the negative remainder. So 7 minus 4 is plus 3, become real remainder, right? That's the example we got here. So in this case, if the negative remainder is minus 1 and the divisor is 9, then the real remainder should be 9 minus 1. Real remainder should be 8. What does it mean? It means the answer should be 8. Okay. This is one easy application of negative remainder. I hope you got it. Let's see more examples. Okay, another example. So you got the you understood that if you have a number as base and the power and then divide by a number, how do you simplify this? How to use negative remainder, right? So let's check some more example and practice it. So here I have a question for you, which is 2 raised to 123 divided by 17. Find the remainder. Okay. Now in previous two questions, we have used the base as it is. But in this case, when you have base like this 2, which is very small compared to the divisor, in that case, you keep increasing the power of this base and check how can you get the remainder closer to 17, or I can say 1. Yeah. Or to tell you straightforward, we are going to check the remainder in the remainder theorem. Whenever you come across the remainder theorem question, you should see how can you get the remainder, how can you get the remainder as 1 or minus 1. Okay, because this is going to help you. This is going to help you in such case where you have big power, because 1 to the power anything it remains 1, and minus 1 to the power even become plus 1, and minus 1 to the power odd will become what? Minus 1, correct? So in such case, you just need to be aware about whether the power is even or odd in case of minus 1, and in case of 1, doesn't matter. Let the power be anything, the answer will be 1, right? So in remainder theorem, now this is a hack for you. In the remainder theorem, look for the remainder 1 or minus 1, right? If you don't get 1 or minus 1, then you will definitely get a pattern when you check with the base and increasing power. Okay, so have patience, sit back, relax, have pen and paper and watch this example. So here, what will I do is I will say, okay, 2 to the power 1 divided by 17, the remainder is how much? Remainder is how much? 2. Now, when I have, just a minute. Okay, when I have 2 raised to 2, which is 4. 4 when divided by 17, the remainder is how much? 4 itself. When I take 2 cube, 2 cube is how much? 8. When 8 divided by 17, the remainder is 8 itself. Now here 2 raised to 4. 2 raised to 4 is how much? 16. When 16 divided by 17, the remainder is 16. Or I can say the negative remainder here to be minus 1. Don't you think so? The real remainder minus divisor. The real remainder minus divisor. Yeah? Don't do 17 minus 16. Huh? Real remainder minus divisor. Minus 1. So we got minus 1 as a remainder. Negative remainder. Now how am I going to use it? How are we going to use it? Let's understand. So now next step is, so after doing this step, so this has to be your step 1 to check for which power you can get remainder, either 1 or minus 1. If you get 1, nothing like it. But if you get minus 1 before that, don't worry, this is also useful for you. Okay, even if you don't get minus 1, when you keep on increasing the power, you're still not getting minus 1. That means you are going to get a pattern. Okay, you are going to get a cycle of remainder in that case. We will see that example also. Currently focus on here. So now 2 to the power 123. Okay, 2 to the power 123. Again, I'm saying that don't confuse this with the unit digit. Yeah, it is different. Now 2 to the power 123 divided by 17, what should be the remainder? I understood that 2 to the power 4, which makes 16, and 16 can give you remainder as minus 1 in case of divide by 17. I will make use of it. I will convert this power 123 as multiple of 4. Okay, so I will apply the property of indices in this case. Property of indices, we have discussed this in the third lecture, surds and indices. I hope you have done that. So I can write this as 2 to the power 4 into 30, which is 120 plus 3. Works? Okay, now don't ask me, sir, how do you divide, how do you get this expression? Arey baba, 123 divided by 4, what you get remainder is 3 and the quotient is 30, so you can write the power as this way. Okay, now divide by 17. Okay, now what will I do? I can write this dividend as 2 raised to 4 into 30 separately, and here plus 3 I'll take separately, so I can write this as 2 raised to 3 as another term, right? Now this part I can write as what? 2 to the power 4 to the power 30. Okay, multiply by 2 cube. Yeah, now as I said, focus on getting remainder. Now this particular expression divided by 17 is very similar to the questions which we have dealt when I was explaining you the concept of remainder theorem here. Don't you think so? One number is 2 to the power 4 into 30 and the other number is 2 to the power 3. Both are in multiplication. You have a common divisor. So to find the remainder, use the same method. Yeah, use the same thing. Okay, so I can say I can take this term separately and this one separately. So 2 to the power 4 when divided by 17, the remainder is minus 1. So here I should write 2 to the power 4 when divided by 17, remainder is minus 1, and power 30 is as it is. Multiply by 2 to the power 3. Now 2 to the power 3 can be written as what? 8. 2 cube is 8, where minus 1 to the power even is what? Plus 1. Correct? So plus 1, so we don't usually write plus as such, we'll only write 1. And 1 into 8 is 8, and this is a number which is smaller than the divisor and it is positive. Smaller than the divisor and greater than equal to 0. So this become your real remainder. This become your what? Real remainder. Yeah? Did you understand how to use this negative remainder for your benefit? Right? Okay. I hope so. Yes, interesting, no? If this is very new to you, very new to you, and you are still not able to understand a couple of steps, I recommend you to watch this example once again. It's easy, simple. You need to understand that whenever you need to find out the remainder when divide by any number, you have a term which is having a base and the power. You take the base, increase the power, and see for which power you're getting the remainder as 1 and minus 1. That's your step number 1. Second step is this. Second step is this. This is your step 2. This is your step 2, where you write the base in terms of the power where you're getting remainder as minus 1. So I need to write the power in terms of 4 multiplied by something. Yeah, multiple of 4. So this is your step 2. Then you split the base. Then you take this both terms separately, and then you get the answer. Yeah. So it's matter of some 3-4 steps. Okay, that's the remainder theorem. Right? Let's take some more examples. Great. So here I got another example for you. When you see this way, so I hope you understand the difference in the power to the power and bracket to power. This we have discussed in surds and indices chapter. Concept, right? So let's check this again. So if you have 2 to the power 3 to the power 4, and if you check 2 to the power 3 to the power 4, what is the difference? Here the difference is when you say 2 to the power 3 to the power 4 and you don't have any bracket. In that case, you simplify the topmost power and say 3 raised to 4 is how much? 81. So this means 2 to the power 81. Whereas here you have what? You have bracket, then powers are multiplied. So this is nothing but 2 to the power 3 into 4, which is 2 to the power 12. Okay, so 2 to the power 3 to the power 4 is totally different than 2 to the power 3 bracket to the power 4. Fine. This is important property to understand for surds and indices. Coming back to the question. So here you can see there is no bracket. What does it mean? It's not 32 into 31. Okay, it's not even 31 to the power 32. Don't treat it like this. So when you don't have any bracket, you simplify the topmost power. You simplify the topmost power. That means you need to simplify first what? What is the value of 32 to the power 31? Yes, that's what you need to simplify. But we know we are answering exam which is not calculation based. It's more of smart work, right? So here you have a divisor which is how much? 7. So let's see how do we treat this. When you have a base which is bigger than the divisor, first of all simplify that. Yeah, I hope you have understood with the previous example that this 30 to the power 31 could be any number, but it's a big number. But that actually means what? This 31 is multiplied by itself so many times. Whatever is the value of this 32 to the power 31, it's a big number. So whatever is the number is, this 31 base is multiplied itself that many times. This is very basic and easy, right? Okay. So now when you take this each number and each number when divided by 7, so these numbers are definitely more than 7. So that we can deduct this base. Yeah. So make a thumb rule. If you have a base which is bigger than the divisor, you deduct the base first. Fine. So 31 when divided by 7, you know, 7 4s are 28. So here this 31, this each 31 remainder, given remainder is what? 3, 3, 3. How many times? Same. 32 to the power 31 times. So can I write this as the remainder? Can I write this as 3 to the power 32 to the power 31? No, it's a basic common sense that 3 multiplied so many times will definitely be more than 7. So this is not your answer. Yeah, we need to go ahead with, we have to go further and get the answer. Fine. So what you do in this case, you take this 3 and you increase the power. Yeah, that's what we have learned in the previous question. Correct? Yeah. We increase the power and we see what can we get as the remainder is 1 or minus 1, or we can see if we have any pattern formed. Okay, so let's see. So now if I simplify this 3 to the power 1 when divided by the remainder which is 7, this gives you remainder, the real remainder. Let me write real remainder also. You don't do this in exam, okay? Don't waste even single second in exam. Now 3 square is what? 9 divided by 7, remainder is 2, not of any use. And 3 is to 3, which is how much? 27 divided by 7. So here you will get remainder as 6, correct? Right? Or you can say the negative remainder, let me change the color here, the negative remainder as when real remainder minus divisor. What you get here? Minus 1. Correct? What you get here? Minus 1. It's of a use. Okay. So then what we'll do? We'll use this minus 1. When are we getting minus 1? When 3 is powered 3. Okay. 1, you can use this. Yeah. You can see what happened when this power is this power 32 to the power 31 when divided by 3. What do you get there? Now challenge is here you have minus 1. So okay, I can write this power in terms of 3 multiplied by something, right? And this time we have to be a little careful about the quotient. Why, let me show you the previous example. Here, if the remainder is minus 1, it is very important for us to understand whether this number is an even number or an odd number. It's very important for us to understand this, right? So I can't simply say that we don't care about the quotient in this case when we have the negative remainder here. We care about it. we do care about it and we need to say whether that is even or odd. Yeah, so you can use it. Now, should I take it forward? Yes, from here. So what we need to keep in mind, we need to understand, we need to remember that we need to understand that when we write this 32 to the power 31 as a power, and I want to make use of this 3, power 3, because 3 cube is giving you -1. So the power here, only power, 32 to the power 31, I should write this as in terms of 3, which should be like 3n plus k. Okay, now then further we'll see how can we simplify, but we should be very clear in understanding this n is what? Is it even or odd? Okay, and I'm here, I'll help you out to understand. Did you understand the concept? Have you understood the concept? Right? Have you understood what are we going to do? Clear, no? It's taking a lot of time because we are understanding, we are building the concept. But once you understand, similar questions you will be able to solve within few seconds. Trust me, you'll be able to solve within few seconds. So let's take it forward. Apply a little bit of common sense also. Yeah, थोड़ा common sense के साथ भी solve करेंगे. So here I have 3 to the power 32 to the power 31. So can you not say that this power 32 to the power 32? Now 32 is an even number. Now even number to the power anything will give you even number only. Think about it. Because what is power? It's nothing but multiply the base that many times. So multiply this even number by itself 31 times. So it's even into even into even into even into even. It's going to be even, right? This is something which is useful for us. Now, next I'm going to do is I want to write this 32 to the power 31 in form of what? 3n plus k, where here if you understand this very well, this k is nothing but a remainder when this value divided by 3, right? Okay, so in power also we are applying the remainder theorem for this case, and this time the divisor is what? 3. Do you understand why divisor is 3? Because I want to convert this into 3 to the power 3 into something, because that's where I'm getting the negative remainder as -1. Important for us. Okay, so this is because of the power 3, yeah? That's not because of the base 3. Okay, right. So now if I do so, I understand that 32 when divided by 3, the remainder is 2 to the power 31. I will first try to identify what is k, which is the remainder. Then 2 to the power 1 when divided by 3, remainder is 2, but 2 square, which is how much? 4 when divided by 3, remainder is how much? 1. So I need to convert the power into 2 multiple something. So this 31 I can write as, just have patience, huh? You are going to understand for sure. Just have patience, just don't give up, huh? Have patience. Okay, now here I can write this as 2 to the power 2 into this 31, right, in terms of 2 multiple something. So 2 into 15 plus 1. Agreed? Okay. So this can be, now this here we are coming to the remainder part, yeah, of the power when divided by 3. And why we are dividing by 3? Because power when it is multiple of 3, I'm going to get the remainder every time -1, -1, -1. That's going to be helpful for us. Now I can apply the indices property and say 2 raised to 2 to the power 15 into 2 raised to 1, which is 2. Okay, this should be the remainder. Now here 2 raised to 2 is giving the remainder as 1 when divided by 3. This is 1 raised to 15 into 2, which is what? 2. So what does this mean? This everything means, pay attention here, this everything means that when 32 to the power 31 divided by 3, the remainder is 2. Or I can say 32 to the power 31 can be written as divisor into a quotient which I don't know, plus, even you don't know, you don't need to know, plus remainder is 2. Okay, this is important for us. Now what more is important? What more is important? More is to understand n. Just understand n, whether it is even or odd. We don't care what is the quotient in this case. We don't care what is the value of n. We just need to understand what type of value is n, even or odd. Can you identify it? Yes, you can. Think about it, yeah. Here it is even to the power anything is even. So this is going to get you what? Even value. So even is equal to 3 is an odd number. 3 is an odd number. Think about it. And n, and plus 2 is an even number, right? Now you are going to get overall value as even only when this is also even. Only when this is also even, because even plus even is the only way to get the even outcome. If not, if it is odd, then odd plus even will become odd, right? So this has to be even. Logic, common sense apply karte chalo dost. Now this term, to have this term even, 3 to pehle se odd hai, 3 is already odd. That means this n has to be even. Only then even multiplied by odd will become overall even, plus even will give you even. So the confusion is n is even here. Got it? We are not, abhi tak answer aaya nahi, huh? Don't worry, but wait, you will get it. Till here, all good? Okay, go back. Here, this divided by 7, we need to find the remainder. We are on it, boss. Yes, now here the power, I can write this power as 3 to the power 32 raised to 31 can be written as 3n plus 2. From where? From here. ये सब जो पंचायती किया है, this is all giving you the outcome, right? 32 raised to 31 can be written as 3n plus 2, right? Okay, now applying the indices property, I can say this is 3 raised to 3 to the power n multiplied by 3 to the power 2. Okay, divided by 7, we need to find the remainder. Okay, now why power was converted into 3 multiple plus something? Because 3 to the power 3 when divided by 7, the remainder is 6, or we can say remainder is -1 as well. So here I can say this is -1 to the power n into 3 to the power 2. I hope you understood the importance of all this step. Why it was important for us to understand whether n is even or odd. Because only when n is even, this -1 raised to even become +1. Otherwise, it will remain -1. So we just need to identify in this case whether power is the quotient when divided by 2 and got the remainder. Quotient when divided by 3 and got the remainder 2. The quotient is supposed to be even or odd. We got it, right? And we identified this to be even. So -1 to the power even will get you what? +1 into 3 square, which is how much? 9. 9 into 1 is 9. Is becoming more than the divisor. The final remainder has to be less than the divisor. And for less than divisor, again this 9 divided by 7, and happily you can write the answer. Happily, with smile on face, 9 divided by 7, the answer is 2, and your answer is 2. Okay? I know it is becoming lengthy because I am focusing on a lot of concepts here. Negative remainder, power further divided by a number, and again identify the remainder. So we applied remainder theorem 2 times here. Then understanding the operation of even and odd, why it is important to understand that. So 3-4 things we have included. That's why it's taking more time. Yeah, but if you know all these concepts, this question can be solved within 30 to 40 seconds, not more than that. Yes, trust me. Yes, it is possible. Okay, let's see some more example. Let's see how much you understood. Okay, let's check some more example. So here 58 raised to 75 divided by 11. Easier than the previous example, right? So if you want, you can pause the video and try this question by yourself. Okay, or we can do it together. So let's do it together. Here we got 58 to the power 75. That's the question, divided by 11. And I hope by now you are comfortably understood that if base is more than the divisor, first of all deduct the base. Yeah, because what does it mean? It means 58 multiplied by 58 multiplied by 58. Yeah, 58 multiply itself how many times? 75 times, and then divide by 11, right? So you take each term and divide by 11. What you get here? You get 11 5s are 55. That means each term is going to get you remainder as 333. How many times? 75 times, right? Now this can be written as 3 raised to 75 divided by 11. Okay, we are still not done because 3 raised to 75 is still more than 11, right? So further we need to divide. So what do we do in such case? We take the base, we increase the power 1 by 1 and check by dividing 11 and see whether what remainder are we getting. And what is our end goal? What is our end goal doing this? The end goal is to check for which power we get remainder 1 or minus 1. If we don't get that, then we may get a pattern, a cycle followed by a remainder of this. Okay, so let's see whether we get a cycle or we get plus 1 or minus 1. Yeah, इनमें से कुछ मिलता है आपको, हाँ, so इनमें से कुछ मिलता है for sure. Either you get cycle of remainders or you get remainder 1 or minus 1 at some point of the power. So 3 is to 1 divided by 11, remainder is 3. 3 square, which is 9, divided by 11, remainder is how much? 9 itself. And if you take the negative remainder, it is minus 2. It's not minus 1, so we are not done yet. 3 cube, which is 27 divided by 11, the remainder is 5. Not of any use. 3 is to 4 divided by 11, 81 divided by 11, remainder is 4, not of any use. 3 is to 3 to the power, one second, just a minute, let me make some space. Yeah, 3 to the power 5. Okay, now abhi kya hai na, suppose if you are not able to or calculate 3 to the power 5. Okay, in case if you are not, you can make use of the previous remainder. See, 3 to the power 5 divided by 11, think about it. 3 to the power 5 divided by 11, to check the remainder, it is nothing but 3 to the power 4 into 3 divided by 11, one of the same thing, right? Now 3 to the power 4 divided by 11, you know the remainder as 4, multiply by 3, yeah, so remainder should be what? 4 3s are 12, but you know 12 is still more than 11, so you can write the remainder as how much? 12 divided by 11, remainder is 1. Yeah, so it's not necessary that you have to actually calculate the power. You can apply remainder theorem within remainder theorem. It works. Okay, there is no issues. Okay, and here we got the remainder as 1 here, plus 1 here. So 3 to the power 5, whatever the value is, when you divide by 11, you are getting the remainder as 1. And yeah, we got the stage where we are getting remainder as 1. We don't have to actually follow the cycle. Okay, so here we got for 3 to the power 5, and the question here is, okay, I had less space. Okay, question here was 3 to the power 75 divided by 11. Okay, we'll keep this in mind. So 3 to the power 75 when divided by 11, we know that here 3 to the power 5 is giving you remainder as 1. So I have to convert the 75 in form of multiple of 5 and plus something minus something like that. So here I can say 5 into 15 and 5s are 75. Okay, and it's exactly multiple of 5, so we don't have to do plus something, like we don't have to write 5 into 15 plus 2 or something. It's exactly multiple of 5. It works for us. And if we simplify, we can apply the indices property. This is 3 to the power 5 to the power 15 and divide by 11 and check the remainder here. I know that when 3 to the power 5 is divisible by 11, the remainder is 1, and 1 to the power 15 divided by 11, remainder will be 1. Got it? Yes, no? Yeah? Okay, so here we have the answer, right? I want to modify the question a bit. What if it is 58 to the power 58 divided by 11? Same thing. What will be the remainder? Pause the video, it's the same number. Pause the video and answer the question. Or we can solve this together. Because 3 to the power 5 and 75 become very easy power to deal with because it is already multiple of 5, right? Here it is not multiple of 5, so let's deal with this. Now, you know that the base is more than divisor, so first of all deduct the base. You can write this as 3 to the power 58. Then you also know that 3 to the power 5 and divide by 11, the remainder is 1. The remainder is 1 here, okay? So I'm going to make use of it. So power we need to write in form of multiple of 5. So you write this as 3 to the power 5 multiply by what plus what can give you 58. So 5 into 11 is 55 plus 3. This is what you can write, correct? So now further if you simplify, this is 3 is to 5 into 11 multiply by 3 is to 3. If you want, you can skip this step and directly write like 3 to the power 5 to the power 11 into 3 to the power 3. And what happens if you divide this by 11? What's the remainder? So here for the first term, this first term, and here the second term. So first term you get what? 3 to the power 5 is giving you remainder 1 when you divide by 11 here, right? Yeah, so this is 1 to the power 11 is 1. 3 cube is 27. Now here we are getting 27. We know that this is still more than the divisor. So you further divide by 21. Further divide by 11. So 27 divided by 11, the answer is what? Answer is 5. 11 2s are 22. So answer is 5. The final remainder is what? 5. And boss, if you got this correctly like this, then you got a grip on the remainder theorem. Yes, you got the grip on the remainder theorem. But still, let's see one more example. What happens when you have 7 to the power 83 and the divisor is 9? What is the remainder? Again, you can pause the video and try attempting the question by yourself. Now here, again we'll follow the same method. We'll check for which power of 7 when divided by 9, we are going to get the remainder 1 or minus 1. Here 1 or minus 1, why are we behind 1 or minus 1 as a remainder? In the case of power, I hope you understood this very well, because 1 to the power anything is 1, minus 1 to the power even is 1, minus 1 to the power odd is minus 1. So that's very defined, right? So that's why we look after, or we keep searching for which power do we get, 1 or minus 1. Okay, so 7 to the power 1 divided by 9, the remainder is 7. 7 square, which is 49, when divided by 9, the remainder is 45, 4, right? Now 7 cube, suppose I don't know. I know, but assume that I don't know. In this case, what will you say when divided by 9? What will you say remainder as? Do you remember? We have discussed in previous question also. If I want to know 7 cube when divided by 9, what is the remainder? I can also split this as 7 square into 7. I can take this as these as two different terms. I can say 7 square has given me remainder 4. Multiply by 7 is how much? 28. Now 28 is still more than 9. So further divide by 9, what you get remainder as 1. Okay. So you can use remainder theorem inside remainder theorem. No issues. That's what I have done here. Got it? Okay. Now, well, here we also got 7 cube giving you remainder 1. So we need to convert the power in terms of multiple of 3. So 7 raised to 83, which is the actual question. 7 raised to 83, which is the actual question, I can write power in multiple of 3 as 3 into, what will you get? 3 2s are 6 and then 2 and 3 7s are 21 plus 2, right? So here you can simplify and say this is, I'm skipping one step because you all are mature now, you are confident about the remainder theorem now. I can write this as 7 to the power 3 to the power 27, the property of indices, multiply by 7 square. Now here, you know, 7 cube and divide by 9, the divisor is still same. Divisor is still same, 9 only, which is given in the question. So 7 cube and divide by 9, the remainder is 1 to the power 27 will give you 1 only. Multiply by 7 square, which is 49. Yeah, again and again I am trying to explain you why this remainder 1 matters, because now you can see 7 cube is giving you remainder 1, power kuch bhi hone do, let the power be anything, you are going to get the end remainder to be 1. So here you get what? 1 to the power 27 is 1, multiply by 49. Is 49 the answer? No, because 49 is still more than 9. So you further divide 49 by 9. Remember, remainder has to be more than equal to 0 and less than dividend, right? Dividend is 9, sorry, divisor, my bad. Divisor less than divisor, and divisor is 9 here, correct? So this cannot be remainder. So 49 further divided by 9, the remainder is how much? 5. That's your final answer. That's your final answer. Aa gaya hai answer. You got the answer. I hope you understood. You are comfortable with the remainder theorem. I know it's different, it's unique, it's unknown, unseen. You know, you have seen percentage earlier in your routine life, percentage discount, profit, ratio, speed, driving car, riding two-wheeler, you understand the speed concept. All those are natural. Your quadratic equation, linear equation studied in the school time, but this is different. So anything which is new to you, you may find it complicated. It is very natural. You are not the only one. Okay. So anything which is new to us, I mean, I was learning Japanese language. I am learning Japanese language, yes. That's the right way. So when I started it, I used to think like, what type of symbols they are? How will I cope up with it? I don't know. How will I make the spelling or word formation, sentence formation with this symbols, which was totally going out of my mind. But then my teacher told me the same thing, that anything which is new to you is going to be complicated. It feels complicated. So it's very natural. Spend some time with it. Go through this lecture once again if you are still not confident about the remainder theorem, and see if you understand all the examples which I have explained, you got the good grip. Okay, so this is it in today's lecture. My name is Shyam Manavat signing off. I will see you in the next lecture. Till then, stay healthy, stay happy, and keep learning. Bye bye.